All right, you've pretty much learned everything you need to know about this lesson, but I wanted to have one final video showing you how to use this with a word problem, all right, in an application situation. So let's look at this. And it seems like, again, a lot of students get really panicked by these because don't just want to read it and struggle through it. And I just want to encourage you, don't be too intimidated by these problems because they're really not as hard as you think they are. So it says Mr. Davies spent $230 on lunch for his class. All right, so he went and bought lunch for his class and spent a total of $230. Sandwiches, all right, and then he's calling sandwiches X because he's going to put this into an equation form. So Mr. Davies must be a math teacher. Sandwiches cost $6 each, and drinks cost $2 each. That's what that means, all right? It says sandwiches X cost $6. Nobody talks like that. Sandwiches cost $6, drinks cost $2. This is represented by this equation, all right? So even if they didn't tell you X and Y from this, you should be able to see, looking at this equation, that this 6, oh, that must be the sandwiches, and then that 2, oh, that must be drinks, all right? So what this means is that whatever combination he gets of these, we want to use the x and y intercepts to graph this equation and basically see what the intercepts are. So I want you to think about this equation in a very practical sense. Now, he has basically 3 different options he can do. He could take all the money and say, I'm just going to buy sandwiches, okay? So if he does that, all right, if he says, I'm just going to buy sandwiches, and he's going to take 6x plus 2y equals $230, that means he's going to solve for this, and he's not buying any drinks. In other words, he's making that 0. This is the equivalent of him saying, I'm finding my x-intercept, right? Because he's only purchasing sandwiches and the drinks are going to be 0. All right, so if he does that, he'll get an equation that is 6x equals 230 because he decided he's not buying drinks, which means they're 0. So if he divides 230 by 6, then that's going to give him, well, 230 divided by 6, I don't believe gives you a nice even thing, because 240 would give you 40 sandwiches. All right, so I'm going to go 230, I'm going to divide it by 6, and I'm going to run out of room up here because I didn't move this. So he's going to be able to get 30 some sandwiches. So 1850, so 38 sandwiches, 38, 48, you get 2, right? And that goes into here, right? 6 goes into 23 times 18, and then you get that repeating 3. So it's 38.33 blah, 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 repeating, right? So x equals 38 and a third, because that's what a 3 repeating means, right? It's 1/3. So 38 1/3. So let's go to 38 1/3 on our x-axis. That's going to be a little before 40. And let's just put a point there. Being totally 100% crazy, like psychotically precise with this is not really that big of a deal, because you have the equation and you can use that for that. So when you're plotting this, you want to be pretty close, but you don't have to like sit and worry about, well, is that actually a third, or just put it about where you think 38 is. Now 2y equals 230. So if he said, you know what, I'm only going to buy them drinks, they're really thirsty and they've been eating popcorn all day, so I'm just going to give them drinks. So let's go 2y equals 230. And the reason we're getting rid of this 6x and we just decided it's not a factor is because x is 0, because he's not buying him any sandwiches. These are the 2 different cases, right? The extreme cases, right? So you have 2y equals 230. So y equals 115. So he can buy 115 drinks if he doesn't buy any sandwiches. And that's going to put us right about up here somewhere. Now, the more likely scenario is that he's going to do some combination of the 2. And what's cool about these things is that you draw this line that kind of goes from one to the other, And you can use this to kind of predict, well, if he buys 20 sandwiches, you go up here, he can get about 60 drinks and then that on his budget. Or if he decides to buy 30 sandwiches, then he can only buy about 30 drinks. So that's what's cool about this. And in doing the problem this way, right, we graphed the equation and we also kind of interpreted the intercepts already. You know, your x intercept basically is he can buy, sorry, I spelled that wrong. He can buy 38.3 sandwiches, which is actually kind of stupid because you can't buy 0.3 of a sandwich, can you? No. So he can buy 38 sandwiches, okay? And then the y-intercept is he can buy 115 sodas, right? Or drinks. I'm assuming they'll be sodas. They're kids. Kids love soda. All right? So I hope that this kind of highlights to you that this is still basically a regular intercept problem, and just kind of looking at it. And a lot of times when you're doing one of these problems, they're written kind of weird, and I think it's up to you to figure out, okay, what's the information I need off of this, and then how can I put this in my brain in a way that makes more sense than maybe the slightly awkward way that it's written. And that's kind of what I tried to model for you, and so I hope that helped. All right, so good luck.